Hi. Hi all. Today I'm here to introduce you to a cutting-edge design approach in Python, class merging. I will also showcase the package implementing this approach, Dyndesign. Let's start from the motivation. I don't know about you, but when I'm coding, especially in those massive and complex projects, I always have in my head this, when if somebody allows you to, these principles and best practices, like mantras, single responsibility, open closed, and all the solids. Don't repeat yourself. Keep it simple, stupid. You aren't gonna need it. It's like kind of mom's advices in your head. It's not easy to follow all of them at the same time, isn't it? Actually, it's a matter of striking a balance between them. Sometimes you feel like you're getting closer to one, but drifting farther from another. And it's not unusual that the one you are drifting away from is precisely the keep it simple. That's like saying that your code is somehow getting more and more complex, less readable, less maintainable. So, hasn't everyone experienced this at least once? Someone nodding, thank you. In contrast, the InDesign approach prioritizes ease of use. This approach stemmed from a question. Why do we merge classes as if they were dictionaries? For example, we have dict1 here, A1, B2, dict2, A3, C4. We merge, for example, with pipe. And the result is a dictionary with all the items of the operands. And where there is a conflict, the items with the values in the rightmost, on the last one, overwrites the left ones. So this is quite easy to understand. I mean, everyone is expected to know this mechanism. It's not even Python specific. It's across language, so it's quite basic. So my question is, why don't we do the same with the classes? We have class base, class ext1, class extension 2, and we have here some function merging classes that returns class merged. And class merged has the same attributes and methods of the components classes. And when there is a conflict, that is an attributed method with two attributed methods with the same name, the rightmost overloads the leftmost. So for example, in this case, A1 is in X2 and also in base, and so is the A1 in X2 overloads the A1 in base. And also M2 in X2 overloads M2, so it's violet and overloads M2 in green. It's quite easy. I explain in a few minutes. It's quite an easy concept too. It's the idea behind Dyndesign is to provide a tool to join classes together as the building blocks. Block building shares some similarities with class merging. Blocks may partially overlap each other, like classes may partially overload other. They connect together using studs and so on. I needed to say, this snapshot is taken from my daughter's playground, just to properly attribute it. I don't want to, when she grows up, she sues me, so just to be clear. To bring this idea to life, I created the package Dyndesign. It's made of 4 modules. The primary is, on the top left, is class merger, which implements, guess what, merge classes. So now this function here has a name, that's its merge classes. And Then the second significant module is the one you can see on the top right, for the cross-class invocation. This basically deals with the communication between merged classes, for example, dynamic decorations between methods of merged classes, and somehow implements the studs of the blocks. If we continue with the metaphor of the blocks, you can think of this somehow with this as the studs. So this is the status. It's been tested with Python from 3.8 to 3.11. It's available on GitHub. Anyone who wants to contribute is warmly welcomed. If you just want to use it, the easiest way is to install via pip. Very easy. It's also extensively documented in the docs. Anyone who wants to deepen this topic. Now, let's do some code. Now we are here. In the second part, I will use as a testing ground the collage sequences. Collage sequences are sequences of integer numbers generated by recursively applying a mathematical function, collage function, from a starting integer number. Collage function is quite simple. It's just a function that when a number is even, it divides by 2, and when it's odd, it multiplies by 3 and adds 1. So very easy to explain, but the sequence, as you can see from this graph, is not as trivial as the function, because, for example, if you start from 27, it has some oscillations, and then it reach up to around 9,000, and then it descends again to 1. Collat's conjecture says that each integer number, at the end descends to 1. It's just a conjecture. Now let's have a look to a script that, how does it work? I made a Python script that just take it as input the number, the starting number, and then it prints out the sequence. If I start with 64, it's quite easy because, as I told you, when it's even, it divides by 2, so it's 64 is the power of 2, so it gets to 1 in a few steps. If instead I try with 27, we got exactly what you're seeing in the graph. So we have a lot of steps that reach up to more than 9,000 and then gets to 1. Okay, now let's take a look at the code of this script. The main body, you can see here, it just deals with I use parse to parse the arguments, or the script arguments, and then calls collats. And finally outputs the sequence. Collats is a function, is a class, sorry, that intentionally violates the single responsibility principle, because I put everything there. So you can see the first half is the first half deals with the sequence itself to calculate the sequence, and the second half from here it just it deals with outputting of the sequence. So yeah, I don't like it, of course. And so to make it a bit closer to the single responsibility, I just do another script. I will show you another script called collats_lib. I show the differences. I just split class collats into class collats sequence and class collats output. I import from Dyndesign merge classes, and then just merge the classes and use it like before. I use collats. Very simple. This is the hello world example, just to show you how does it work. Does it work? Let's see if I have in cache collat split. Okay, we'll type. I didn't want to type here because I'm a little bit unbalanced, but I have no way to do. So collat split, it behaves exactly like the other, as you expected. So result. Let's now let's get to the next level a bit. So the next thing I want to do is add another option to this. I would like another option. Let's say, assume I invented another collage function so that generate another collage feature. My function, the function I invented, is ternary. Is a ternary function. So what I will do first. I will show you another script that is collage ternary. And so I will show directly the difference between collage split and collage ternary. So what did I do is tell argparse that I have another, I will show you a little bit better, another option, C. And when I set this option, when I pass to the script this option C, it will, and I have an if for this, merge in turn another class, which is collage custom, as you can see here. Collage custom is a new class that does exactly what I've shown you before, overloads some attributes and properties of other classes. For example, underscore name, the attribute underscore name, which is the name of the function, overloads this one from collage sequence, and the method getNextN overloads this method getNextN from collage sequence. So in alternative, we use this, that is the function that I told you I invented. That is a ternary function because it's based on a tripartition of the integers. Let's test it. So the name of this is collage ternary. Let's see what happened with, okay, first, of course, if I didn't put the option, it still work, okay, this is, you may expect. Let's see what happened if I put the option. If I put C, you can see that since my function is basically divided by 3, the number that are divisible by 3, so 27, it's 3 powered by 3, so it in 3 steps, 1, 2, 3, 4, gets to 1. Instead, if I launch with, for example, with 64, you can see that it's a little bit longer than, it takes a little bit more time to get to 1 than the original collage function. So have you seen it? I added another option in a quite seamless way. So the idea is that this class can be or cannot be merged with the other depending on my choice, and this choice is made at runtime. This merging. Okay, now let's take a look at the code of collage ternary. Can I say that I am satisfied by this code? Not at all. Not really, at least. Because, as I told you, in my head, I have these principles that, in particular, when I see this, I have like a dry alert, don't repeat yourself alert, because I repeated this. Not only, one may say, yeah, that is just 2 lines, okay, but you must consider, I expect that I will add, I will show you now, I will add more options. So imagine each option, you have an if, I don't like at all. Also, it doesn't fulfill the open-close principle, because we can say that it's open for extension this way, because every time I have to change the script. But also the most important, of course, is that all the classes are here. So all the classes are in the script, and that's really, if you consider the single responsibility principle in a broader way, actually, it doesn't meet at all, because each class should stay in its should be placed in its own module. So what we need here? We need a builder. We need we can use a builder design pattern. A builder design pattern using merge classes. To do this, I need another feature of merge classes that I'm showing you here. Merge classes actually allows you to dynamically import directly the classes by passing them as dot annotated strings. Let's say, for example, I want to merge class base with class x that is in module underscore x.py that is in a certain directory. I just pass as second argument directory.modulex.text, and everything works automatically. Everything works automatically. The class is loaded and then merged. So when I have this feature, when I can count on this feature, I just can use this script instead of the other. You see, just I got rid of the classes, as each class is now in its own module, which is in turn in the directory component. So collats output, collats sequence. Each class has been moved there, and so now the script just deals with the argparts argument, which is what is intended, it's supposed to do, basically. Then this is the new part where it loads a builder, a class builder, and the builder builds the class. Once we have the class, we do as usual, we call output sequence. Let's see if it's work again, because I always need to test, to show that what we did is correct. Allora, let's build merge. We do some tries, 27. We try some. You can see it's worked exactly like before. Now I won't show you all the cases. And now so what we have now? Well, we have something much closer to the single responsibility, but also to the open close principle. Let's test it in action. Let's try to add one more option. I wanna, for example, show everything in instead of showing the result to print out the result. I wanna show them in a graph. Okay. So what will I do? I will add a. Perché? Oh, lo faccio a mano. I will add another option here. I will add another option here that is collats graph, but it is -g, which is related to the class collats graph. By the way, I didn't tell you one important thing. In order to make the builder work, I use a trick. I just put as a destination the name of the class. So, for example, when I set C, I have the destination variable is collats custom. When I add G, I have collats graph. So the builder, I didn't show neither the builder. The builder just, I don't want to spend too much time to the builder, but just to show you how does it work. The builds the class, the main function of the build builds the class by simply populating a list of class names depending on the options, then convert them to paths in dot notation, and then finally merge only once. So that's how does it work. I want to add another, as I show you, another function, another option G. I just add this line, and then collats graph, I already prepared, has is this one. So it has, as you can see, a constructor init, output, and another function, output number, and another function to the output the graph. Now, there's something wrong here, according to what I told you, because function called graph has an init as a constructor, and also function called sequence as a constructor. So according to what I told you, you will say, oh, this overloads the other. No, it doesn't, because when I build the module, I, of course, took into account that when you have a constructor, you want that every constructors are executed. You don't want the overloads. And it's exactly what happens when you merge a class. So let's say that you have a class with that accepted, for example, one position argument, another accepted 3, and some keyword arguments, another 2, whatever. When you instantiate the class merged with the arguments, there is a mechanism that adaptively filters the arguments. So each constructor takes exactly what it needs. So in this case, this does differently from the other. Doesn't need any argument, and okay, it works. It just initializes the sequence. Then output number, instead of outputting the number, just append the number, and finally I would need to call this function output graph. So one way would be to add another if at the end of the script, and I could say if argument, then if merge and call the function to output the graph, but that I would go against everything I told you until now. I don't want to put another if here. So what I will use a decorator. Dynamic decorator, of course. So I would dynamically decorate the method output sequence. I use decorate with, which is one of the components, remember the module cross-class for the cross-class communication. So I will use decorate with passing the argument output graph. And this will work. If I would decorate directly with output graph, it wouldn't work because it's not statically there. But I can do this. So when I do this, means when the option is set, the method is decorated. So when I do something like this, I have a graph. I have a graph here with instead of printing out to the screen, I have as a graph. So for example, this Dyndesign is very easy with my custom function. Yeah, if I use the original collage function, you see I get exactly the graph that I showed you before. One may say, yeah, it's okay, but now the number are not printed anymore to the screen, and I don't like it. I also want to see the numbers on the screen, etc. Okay, no problem, because I can do something like this. I can do something here. I have one more argument here I can put here. It's called invoke all. And I can pass to this argument exactly the name of the methods that I want to be executed all like scusate, like come si fa qua? Like ecco, scusate un attimo, ho intrecciato qua, vabbè, ce lo scrivo a mano. Like in for constructors. Vediamo un po' se funziona. Ecco qua. Now you see both the graph and the numbers printed. So now let's do some takeaways. So now you will learn. Classes can be merged as dictionary using merge classes. Can be dynamically imported and merged from, for example, from a builder so that to adhere to the OCP. Methods and attributes with the same names are overloaded except for instances of init and the arguments passed to invoke all. And finally, decorate with can be used to decorate methods with other methods that can be anyhow loaded, whatever, created dynamically. So some links, contacts, repos. You can find all the code here on GitHub. There are some articles on Medium. You can connect to me, 640medium.com, LinkedIn if you want to connect. Drop me an email, whatever. Thank you.
Okay, thank you very much. First question. First slide. Example merged instances. After you talk about merging classes.
We
can to go. One second. We can use inheritance, MRO, and type. Where is the benefit of merged classes?
Actually, it's a good question. It's I would need maybe all the time for to reply to each part of this question. I will start. I will do for example inheritance. Inheritance, class composition. We could do many. First, inheritance basically static, so you cannot do it dynamically. Actually, it's with inheritance. It's you can think merging class complementary to inheritance, because when you have some two hierarchy, for example, of classes, and you merged each class at each level is merged with the other at the same level. So, for example, if you have a parent and child, another parent and another child, that you merge class, you merge childs and parents. So you can keep the structure inheritance merged. So, for example, you can do some interesting things, like you can call from one child the parent, a method from another parent. You may say, yes, but this way is you have issues if you call it standalone. I mean, if you just call one, if you instantiate one class and call that method that doesn't exist, because you don't merge, then it will you have an exception. And for this, for this reason, in the second module, cross-class invocation, the second, I didn't tell because of lack of time, the safe method invocation, there are two tools. One is the safe zone context manager, and one is the safe invoke. It's just you can call methods cross-class so that when they are not there, you won't have the exception. It will run. The execution will continue normally without exception. You can also you can also pass a fallback function when it doesn't find it. So it's full of options. Everything is explained in the document, in Read the Docs. There is also an example of this in Read the Docs. What happened when merging a class? Same with class compositions. With class composition also. Basically, the difference between class composition is the overloading. This way, with class merging, you can overload the methods. So it's quite you can see that it's like it's not like it's in a way inheritance but dynamic, and also class composition with overloading, you can say. But this is a very simple way to do it, just if you want to summarize in one sentence.
Thank you very much. We don't have time for any more questions. Please search for the speaker and talk.
Okay.
Thank you.